Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'll be working through 11 fraction problems that should closely mirror what you'll see in both the mathematics knowledge subtest as well as the arithmetic reasoning subtest of both the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet Delivered Computer Adaptive Test, that is the PiCAT. In order to get the most out of this video, you'll want to pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. As always, I'll include timestamps in the description of this video. Next to the timestamp will be the topic that the question's testing, and there I'll also include a link to one of my videos where you can learn more about that topic. As always, you're not permitted to use a calculator or reference sheet on the actual ASVAB or PiCAT. So as you work your way through these practice problems, try not to use any of those resources. Finally, I want to say this, having made ASVAB test prep videos for over a year now, I feel as if this is about as close to the real test as you can get. So for that reason, I want to stress this. If you can work through these 11 fraction problems, you should be good to go on test day. And as you'll see, more than half of them are pretty easy to solve. For that reason, I don't recommend that you pay for tutoring. Again, I have all the resources you need to succeed on both the ASVAB and PiCAT on my channel already. And what's more, this practice test should show you that with a little bit of preparation, you should be fine on test day. So having said all that, let's go ahead and get started with this practice test. All right, so as you can see, the first question says, what is the reciprocal of 3 and 1/2? Well, in mathematics, to find the reciprocal of a number, we simply place that number under 1. So in other words, to find the reciprocal of a number n, we would say it will be 1 over n. Well, in this case, we're trying to figure out what the reciprocal of 3 and 1/2 is. So that's going to be 1 over 3 and 1/2. Now, at this point, some of you are probably saying, well, I don't see 1 over 3 and 1/2 as an answer choice. And here's why. In order to match this to one of our answer choices, we're going to have to do some work. More specifically, the first thing we have to do is express 3 and 1/2 as an equivalent improper fraction. And that's pretty easy to do. We know our denominator is not going to change. That said, to find our numerator of our improper fraction, we do 3 times 2, which is 6, plus 1, which is 7. All right, so this becomes 1 over 7 over 2. And again, you're probably saying to yourself, well, I don't see this as an answer choice. And that would be correct. We can read this as division as well as a fraction. As a fraction, this says 1 over 7 over 2. As division, this says 1 divided by 7 over 2. All right, so in other words, we're dividing here, and we could write it out like this if it's more helpful. 1 divided by 7 over 2. And by doing this division here, we'll ultimately figure out what the reciprocal of 3 and 1/2 is, and we'll probably see an answer choice that matches what we have here. Well, how do you divide a whole number by a fraction? The first thing you want to do is rewrite your whole number as a fraction by placing it over 1. Again, you can express all whole numbers as fractions by placing them over 1. So if I told you to write 5 as a fraction, you would say that's simply going to be 5 over 1. Again, fractions can be read as division. 5 divided by 1 is 5. All right, so we have 1 over 1 divided by 7 over 2. Well, how do you divide fractions? You follow the algorithm keep, change, flip. This keep refers to this first fraction. You keep it the same, so that's going to stay as 1 over 1. Change refers to this division symbol. You're going to change that from division to multiplication. And flip refers to this second fraction. You're going to go ahead and flip it. So instead of being 7 over 2, it's going to be 2 over 7. And now when you multiply fractions, you just multiply straight across. This becomes 1 times 2 over 1 times 7. 1 times 2 is 2. 1 times 7 is 7. So the reciprocal of 3 1/2 is 2 over 7. Again, reciprocal is defined as 1 over that number. And of course, when you're working with fractions, placing 1 over a fraction prompts you to do all this extra work as well. All right, so number 2 says, what fraction of the total number of squares is shaded? So in order to write our fraction, we're going to need two things. We're going to have to place the number of shaded squares in our numerator, and that's going to be over the total number of squares in our denominator. And as it happens, those things are pretty easy to figure out fairly quickly. Again, let's analyze this figure. We have a block that is 1, 2, 3, 4, 5, 6 wide by 1, 2, 3, 4, 5, 6 high. So in other words, we have a 6 by 6 block of squares, which means that there are 36 little squares inside this block in total. So our total number of squares is 36. All right, let's work on finding the total number of shaded squares. Well, again, this is 6 high. So I know in this column right here, there are 6 squares shaded. In this column, there's 1 minus 6 squares shaded. So that's going to be 5. And in this column, there's just 1 shaded square. Let's add this up. 6 plus 5 is 11, plus 1 is 12. So 12 of our 36 squares are shaded. Of course, this isn't one of our answer choices, which means we must be able to reduce this fraction. And it should be pretty obvious that both 12 and 36 are divisible by 12. So let's reduce this by dividing both of those by 12. 12 divided by 12 is 1. 36 divided by 12 is 3. So in other words, 1/3 of these 36 squares are shaded. And that, of course, is answer choice B. All right, so number 3 here says, if a box of nails weighs 1 5/6 pounds, then what is the weight of 12 boxes? All right, so we know the weight of one box of nails is 1 5/6 pounds. To find the weight of 12 boxes, we're simply going to multiply that by 12. All right, so at this point, some people are probably stuck as to how to proceed. And here is the next step. You want to rewrite our mixed number, notably 1 5/6, as an improper fraction. And then after that, you want to write 12, a whole number, as an improper fraction, which will enable us to multiply fractions together. So let's work on rewriting 1 5/6 as an improper fraction. Again, our denominator is not going to change. That said, to find the numerator of our improper fraction, we do 1 times 6, which is 6, plus 5, which is 11. Of course, this is times. And how do we write whole numbers as improper fractions? We simply place them over 1. Again, 12 divided by 1 is 12. All right, so now that we've rewritten both of these as improper fractions, we can go ahead and multiply our fractions together. Again, when you multiply fractions, you just multiply straight across. So this becomes 11 times 12 over 6 times 1. All right, so you could do 11 times 12, 6 times 1, and then work that out. But that said, on test day, you want to work quickly and efficiently. So what I'm going to do is say 6 goes into 6 one time, 6 goes into 6, 6 goes into 12 two times. So this becomes 11 times 2 over 1 times 1. What is 11 times 2? That's 22. What is 1 times 1? It's 1. 22 divided by 1 is just 22. All right, so in total, our 12 boxes of nails that weigh 1 5/6 pounds each weigh 22 pounds. All right, so number 4 says, if 1/4 divided by 2/7 equals C, then what is the value of C? So if it's helpful, you can always quickly rewrite this one to be C equals 1/4 divided by 2/7. Sometimes people find it easier when the variable for which they're solving is on the left. All right, so what are we doing right here? We are dividing two fractions. We have 1/4 divided by 2/7. Well, in order to divide fractions, you follow the algorithm keep, change, flip. Keep refers to this first fraction, you keep it the same. Change refers to this division symbol. You change that from division to multiplication. Flip refers to the second fraction. Instead of being 2/7, you're going to flip it to be 7/2. Now you're just multiplying two fractions, which means you're just going to multiply straight across. So this becomes 1 times 7/4 times 2. 1 times 7, of course, is 7. 4 times 2 is 8. All right, so 1/4 divided by 2/7 is simply 7/8. So number 5 says a pizza pie was cut into 8 equal pieces. A person who eats 1/2 of one piece eats what fraction of the total pizza? All right, so we know we're dealing with a pizza here. What's more, we know our pizza is cut into 8 equal pieces. And in light of that, we know each of these slices of pizza represents 1/8 of the total pizza. And according to the question, we want to know what fraction of the total pizza someone eats when they eat half of a slice. Well, a slice is 1/8 of the total pizza. If we're eating half of that, we're going to take 1/8 and we're going to multiply it by 1/2. And that will tell us what fraction uh, the person ate of the pizza. And as you can see, we're simply multiplying two fractions here. So we're going to multiply straight across. This becomes 1 times 1 over 8 times 2. 1 times 1 is 1. 8 times 2 is 16. So if a person eats 1/2 of a slice of pizza, that means that they're eating 1/16 of the total pizza. So number 6 says it takes 3 glasses to make 1 quart. If a glass is 1/2 filled, what part of a quart is in the glass? So this problem can be, at first glance, a little bit confusing because most people would say, oh, there are 4 cups in 1 quart. Well, pay attention to this wording. This says glass, and a glass is not a standard unit of measurement. So this has nothing to do with the fact that there are 4 cups in a quart. All right. Instead, you should realize that this is a proportion problem. And the way you set up proportions is like this. You set two fractions equal to each other. Using the information that you know already, you fill in the left-hand side of the proportion. And on the right-hand side of the proportion, you put the information you're trying to figure out. So what do we know already? Well, according to the problem, it takes 3 glasses to make 1 quart. What are we trying to figure out? Well, according to the problem, we want to know what part of a quart is in the glass if a glass is 1/2 filled. So if we have a glass that is 1/2 filled, so that's a half of a glass, we want to know what part of a quart is in the glass. Well, that's an unknown. So in math, we can represent unknowns with letter variables. In this case, I'm going to call that x. So that's going to be x part of a quart. All right, so we set up our proportion, and the question is this. How do you solve proportions? Well, you cross multiply. You do 3 times x, which is 3x. And then you do 1 times 1/2, which is 1 times 1/2. All right, so let's go ahead and work this out real quick. This becomes 3x equals, what is 1 times 1/2? It's just going to be 1/2. All right, so by solving this equation for x, we'll know what part of a quart is in the glass. And to solve for x, we're going to divide both sides by 3. This crosses out here, leaving you with x on this side. Well, right here, as you can see, we have 1/2 divided by 3. You should realize that we can write 3 as a fraction by placing it over 1. And now this problem involves the division of two fractions. Well, how do you divide two fractions? How would you do 1/2 divided by 3 over 1? Because these are the same things. I just rewrote this. Instead of using a fraction bar, I used a division symbol. How would you solve this? Well, you would use the algorithm keep, change, flip. Of course, keep says keep this first fraction the same, so we'll keep 1/2 as is. Change refers to division. We're going to change that from division to multiplication. Flip refers to the second fraction. Instead of being 3 over 1, it's going to be 1 over 3. And now we just have a multiplication problem involving two fractions, which means we're going to multiply straight across. This becomes 1 times 1 over 2 times 3. 1 times 1 is 1, 2 times 3 is 6. So 1/2 divided by 3, or 3 over 1, is 1 over 6. And to answer this question, what part of a quart is in the glass? 1/6 of a quart is in the glass. So number 7 says a television show is 60 minutes long. During this show, there are 4 1 1/4 minute commercials. Approximately what percentage of the show is a commercial? All right, so we're trying to answer this question. What percentage of the show was a commercial? So to do that, we have to figure out the total minutes of commercials. And let me make sure I spell that correctly. And then we're going to divide that by the total length of the show. And as it happens, we were given one of these things. More specifically, we were told that the show itself is 60 minutes long. So let's go ahead and fill that in accordingly. All right, so clearly, in order to figure out what percentage of the show was a commercial, the only other thing we have to figure out is the total minutes of the commercials. Well, we were told right here that there are 4 1 1/4 minute commercials. So that looks like this. We have one commercial that's 1 1/4 minutes. We have a second commercial that's 1 1/4 minutes. We have a third commercial that's 1 1/4 minutes. And we have a fourth commercial that's 1 1/4 minutes. And by adding all those together, we'll figure out the total minutes of commercials there were during this show. So one thing you could do is you can convert all of these mixed numbers to improper fractions and then add them together. Of course, that would be pretty slow and time consuming. So what you want to do in this case is break these apart. You want to add your whole numbers together. And our whole numbers are simply 1. 1 plus 1 plus 1 plus 1 is 4. So that's 4 minutes worth of commercials right there. And then let's add our fractions together, notably 1/4 plus 1/4 plus 1/4 plus 1/4. And to add fractions, you have to ensure that they all have the same denominators. As you can see, all of our denominators are 4 in these fractions. So we'll just go ahead and bring over our denominator. And now when you add fractions, you just combine your numerator. So that's 1 plus 1 plus 1 plus 1. 1 plus 1 plus 1 plus 1 is 4. So this is 4 over 4. 4 divided by 4 is 1. So that's an additional minute worth of commercials. So in total, we had 4 minutes plus 1 minute worth of commercials. So 5 of the 60 minutes of this show were commercials. And now we have to convert that fraction to be a percent. Of course, one thing you can do prior to doing that is to reduce this fraction. You should realize that both 5 and 60 are divisible by 5. 5 divided by 5 is 1. 60 divided by 5 is 12. All right, so now we have our work cut out for us. We're converting the fraction 1 over 12 to a percent. The first thing we want to do is convert that to a decimal. And the way we do that is by reading this fraction as long division. That is to say, I would read this as 1 divided by 12, like that. And we start this long division by asking ourselves, how many times does 12 go into 1? Since 12 does not go into 1, we add a 0 above the 1 to indicate that it did not. Then to proceed, we have to add a decimal here and a couple of zero placeholders. Once we add that decimal, we're going to bring that up into our answer. And now the question is, how many times does 12 go into 10 without going over? 10's too small, so 12 does not go into 10, so that's going to be another 0. And finally, we ask ourselves, how many times does 12 go into 100 without going over? Of course, that's going to be 8, and you should know your 12 times tables. 12 times 8 is 96. 100 minus 96, of course, is 4. And now we drop down this 0. Now the question is, how many times does 12 go into 40 without going over? Well, 12 times 3 is 36, and that's as close to 40 as we can get without going over. 40 minus 36 is 4. And again, we have as many zeros here as we need. And you should see that this is just going to repeat. This is going to be 8, 3, 3, 3, 3, 3, 3. So 1/12 is the same thing as 0.08333. Repeat it. And we want to convert that to be a percent. To convert a decimal to a percent, you simply multiply it by 100. And when you multiply a decimal by 100, you simply take that decimal place and you shift it 2 times to the right. So this becomes 8.33%. Of course, we were asked to approximate that, and that's going to be approximately 8.3%. All right, so that is that one. So number 8 says 2 farmers bought a truck. The first farmer paid 4/5 of the price of the truck, and the second paid the rest. If the first farmer paid $9,600 for his share of the truck, then what was the total price of the truck? So for this one, it's going to be helpful to convert this word problem into an equation that you can then solve. And that's not that difficult to do. It says the first farmer paid 4/5 of the price of the truck. And let's go ahead and work on converting this to an equation. It says right here, 4/5. In math, we typically associate the word of with multiply. And of course, we don't know the price of the truck, so that's an unknown. So I'm going to put P there to represent the price of the truck. All right, so our equation so far is this: 4/5 times P, referring to the price of the truck. And we're told that 4/5 of the price of the truck is $9,600. So that is equal $9,600. All right, so by solving this equation for P, we'll know what the total price of the truck was. And if it's helpful, you can rewrite this like this: 4/5. Instead of writing times P, you can just simply write P equals 9,600. All right, so clearly we got to get P equal to something by itself. To get rid of this 4/5 in front of P, we're going to multiply it by its reciprocal, notably by 5/4. And we're going to do that to both sides of our equation here. This crosses out here and here, leaving you with just P on this side. And as you can see, we have P equals 9,600 times 5/4. Is there a way we can make this math a little bit easier to do? There is. We can do 9,600 times 5/4. We can express 9,600, a whole number, as a fraction by placing it over 1. And as you know already, to multiply fractions, you just multiply straight across. So this becomes P equals 9,600 times 5/1 times 4. All right, so ideally, we want this math to be a little bit easier. So before I proceed and do 9,600 times 5, I'm interested to see if I can reduce this before doing that multiplication. And I'm fairly certain that 9,600 is divisible by 4. Let's go ahead and check that out because that's going to make the math 10 times easier. How many times does 4 go into 9? That's going to be 2 times, given that 4 times 2 is 8. 9 minus 8 is 1. Drop down this 6. Well, we can also drop down these two zeros if we want, because I know 4 goes into 16 4 times, which means 4 goes into 1600 400 times. 4 times 400 will be 1600. Therefore, there's no remainder. All right, so I'm going to do this over here so you can see it a little bit easier. We have P equals 9600 times 5 over 1 times 4. And thanks to this, I know I can do this. I can say 4 goes into 4 one time, 4 goes into 9600 2400 times. And this problem becomes this: P equals 2400 times 5 over 1 times 1. What is 1 times 1? 1 times 1 is 1. So this becomes 2400 times 5 over 1. And let's go ahead and work this out. I can't do that mentally, so I'm going to do that off to the side. We have 2400 times 5. 0 times 5 is 0. 0 times 5 is 0. 5 times 4 is 20, so bring down a 0, carry a 2. 5 times 2 is 10 plus 5 times 2 is 10 plus 2 is 12. So this is 12,000 over 1. Anything divided by 1 is itself, so 12,000 divided by 1 is just 12,000. In other words, the price of this truck, the total price of this truck is B, $12,000. So number 9 says if 4 over 3 times 3 over 4 equals 5K, then what is the value of K? So we have 4 over 3 times 3 over 4 equals 5K. If it's helpful, you can quickly rewrite this one like this: 5K equals 4 over 3 times 3 over 4. Well, what do we have going on this right-hand side of the equation? We're simply multiplying two fractions, notably 4 over 3 by 3 over 4. When you multiply two fractions, you just multiply straight across. So let's go ahead and do that. We have 5K equals 4 times 3 is 4 times 3 over 3 times 4. Okay. 4 times 3 is 12. 3 times 4 is 12. 12 divided by 12 is 1. So this becomes 5K equals 1. Again, we're trying to find the value of K, so we're solving for K. So our next step is to divide both sides by 5. This crosses out here, leaving you with just K on this side. And as you can see, K is equal to 1/5. All right, so the answer to this one is A, 1/5. And all we had to do is multiply those two fractions together and then solve for K. All right, so number 10 says using 22 over 7 to approximate pi, find the area of a circle that has a diameter of 4/5 of a centimeter. Express your answer as a fraction. All right, so ultimately we're going to be finding the area of a circle, and that's one of the formulas that you do have to memorize for the ASVAB. That's area equals pi r squared. So in order to find the area of a circle, you have to know the radius of a circle. Well, in this problem, we were told that the diameter of this circle was 4/5 of a centimeter. Clearly, we have a little bit of an issue right off the bat because we're given the diameter, but we need the radius in order to solve this one. Well, you should know that there is a relationship between the diameter and radius of a circle. Notably, you should know that the diameter is always twice as long as the radius. That is, diameter is equal to 2 times r. All right, so what we can do to figure out what r is plug in 4/5 for d, and then by solving for r, we'll know what the radius is. So let's solve for r. Let's divide both sides by 2. This leaves us with just r on this side. And as you can see, we have r equaling 4 over 5 divided by 2. Well, what does this look like? This looks like the division of two fractions. And again, you can express a whole number as a fraction by placing it over 1. So I can rewrite 2 to be a fraction by placing it over 1. And now you can clearly see that to find r, we have to divide these two fractions. And as I've stated in this video already, to divide two fractions, you follow the algorithm keep, change, flip. Keep refers to this top fraction. You keep it the same, so that's going to be 4 over 5. Change means you change from division, which we have right here, to multiplication. And then flip, or F, refers to this bottom fraction. Instead of being 2 over 1, we're going to flip it to be 1 over 2. And now we have a simple multiplication problem. Again, when you multiply fractions, you multiply straight across. So this becomes 4 times 1 over 5 times 2. 4 times 1 is 4. 5 times 2 is 10. And we could, of course, reduce this since 2 goes into both 4 and 10. 4 divided by 2 is 2. 10 divided by 2 is 5. So by doing some simple arithmetic there, we know our radius is 2/5. In other words, r is 2 over 5. All right, so now that we know what r is, we can go ahead and plug it into our area formula. So let's go ahead and do that. To find the area of a circle, as I said, it's pi times r squared. In this case, we're told to let pi be approximated by 22 over 7. So let's plug that in for pi. This becomes 22 over 7 times radius squared. We know our radius is 2/5 of a centimeter, and of course, that is squared. All right, so now we got to work this out. And according to your order of operations, you do exponents before multiplication. So we got to take care of this 2 over 5 squared before we proceed. And you should know that this square applies to both of these terms equally. So this is going to become 2 squared over 5 squared. 2 squared, of course, is the same thing as 2 times 2, which is 4. 5 squared is the same thing as 5 times 5, which is 25. So this becomes 22 over 7 times 4 over 25. And let me go ahead and clean that up over here. We have 22 over 7 times 4 over 25. That is to say, we're multiplying two fractions now. And when you multiply two fractions, you just multiply straight across. In other words, this becomes 22 times 4 over 7 times 25. Now, if you can't do this math mentally, you can always do it off to the side. Again, 22 times 4, we can write like that. 2 times 4 is 8. 2 times 4 is 8. So this is 88. And if you can't do 7 times 25 mentally, you can always do it off to the side. We have 25 times 7. 5 times 7 is 35, so drop down a 5, carry a 3. 2 times 7 is 14. Plus 3 is 14, 15, 16, 17. So this is 88 over 175. And it's going to be centimeters squared since we're talking about area. So the answer to this one is D, 88 over 175 centimeters squared. And as you just saw, we had to combine our knowledge of dividing fractions, squaring fractions, and multiplying fractions with our knowledge of circles, including how to find the radius of a circle when we only have its diameter in order to answer this one. And yes, ASVAB and PiCAT questions do get this involved, especially if you're going to score above a 95. Number 11 says, in an auditorium, 1/6 of the students are fifth graders, 1/3 are fourth graders, 1/4 are third graders, and the rest of the students are second graders. If there are 96 students in the auditorium in total, then how many of them are second graders? So clearly, we have to figure out what fraction of students are second graders. And one way you could do that is like this. We can use a 1 to represent the total number of students in the auditorium. Then we can subtract out the 1/6 of the students who are fifth graders, the 1/3 of the students who are fourth graders, and then the 1/4 of the students who are third graders. And by subtracting out the fifth graders, fourth graders, and third graders, we'll figure out what fraction are ultimately second graders. So let's go ahead and work on doing this. As you can see, this is a fraction problem. And the first thing I want to do is rewrite this 1 so that it is also a fraction. As I've said in this video multiple times, you can write whole numbers as fractions by placing them over 1. So this becomes 1 over 1 minus 1 over 6 minus 1 over 3 minus 1 over 4. All right, so in order to subtract these fractions, they all have to have the same or a common denominator. And as you can see, we have denominators of 1, 6, 3, and 4. Well, what do 1, 6, 3, and 4 all go into? They all go into 12. So we're going to rewrite all of these such that they have a common denominator of 12. And that's pretty easy to do. To write 1 as 12, we would multiply it by 12, and we're also going to have to do that to its numerator. Again, 1 times 12 is 12, 1 times 12 is 12. To write 6 as 12, we're going to have to multiply it by 2. We're also going to do that to its numerator. Again, 6 times 2 is 12, 1 times 2 is 2. To write 3 as 12, we're going to have to multiply it by 4. We're also going to do that to its numerator. 3 times 4 is 12, 1 times 4 is 4. To write 4 as 12, we would have to multiply it by 3. We're also going to do that to its numerator. 4 times 3 is 12. 1 times 3 is 3. All right, so now we can perform this subtraction. Again, when you subtract fractions, the denominator does not change. That said, you do the subtraction in your numerator like this. 12 minus 2 minus 4 minus 3. All right, and let's go ahead and work this out. This simplifies to 12 minus, what is 2, 4, and 3? Well, 4 and 2 is 6. 6 and 3 is 9. So this is 12 minus 9 over 12. 12 minus 9, 9, 10, 11, 12. So that's going to be 3 over 12. So 3 over 12 of the students are second graders, and we can reduce this fraction if we want, since both 3 and 12 are divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So 1/4 of the students are second graders. The question is this, uh, in terms of the number of students, what is 1/4 of 96 students? So we'll take 96 and we'll multiply it by 1 over 4. Again, now we're multiplying a whole number by a fraction. So we're going to place this 96 over 1. Now we're multiplying two fractions, and when you multiply two fractions, you just multiply straight across. This becomes 96 times 1 over 1 times 4. In other words, 96 times 1 is 96. 1 times 4 is simply 4. We already saw a problem that was very similar to this one in this video. But that said, we can always do this off to the side. Again, I could read this as 96 divided by 4. I start by asking myself, how many times does 4 go into 9 without going over? 4 times 2 is 8, which is as close as we can get to 9. 9 minus 8 is 1. Drop down this 6. 4 times 4 is 16. And since we have a remainder of 0, we know we're done. 96 divided by 4 is 24. So 24 of the students are in second grade. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. You may have noticed that as you worked your way through this practice test, the questions got progressively more difficult. And I did that intentionally. Again, both the ASVAB and PiCAT are computer adaptive tests, which means that the better you do on those tests, the harder the questions will get. So hopefully you found that aspect of this video helpful. If you want to help my channel out, you can do one of two things. One, you can subscribe to it. And two, you can also share links to my resources on social media, including on Facebook and Twitter. And on that note, I'm going to go ahead and cut you loose.